Alan Stratton from As Wood Turns. Well, remember November? Well, unfortunately there's not a Christmas ornament challenge this year, but it doesn't mean that I can't make a Christmas ornament. Remember, there's all the past years back there on my website, so if you need inspiration for your ornament, please go there. There's a lot of incredible stuff there. Meanwhile, I'll make this one. This is redbud and hazelnut. It uses many of the techniques for the center thing as the pumpkin I turned a few weeks ago. So let's make this Christmas ornament. The main part of my ornament is a small piece of redbud harvested a couple of years ago from my yard. Let's round it off with a bowl gouge and cut a tenon with a skew. With the wood mounted to the chuck, I can drill a 1/4-inch hole suitable for a pen mandrel. This hole will serve two purposes in the future: a way to mount the top and bottom finials, and a way to align the wood when we shift to multi-axis turning. The wood is now mounted to a pen mandrel. Since the axis may have shifted slightly, I'll take a couple more strokes to round it off again. Now it is a good cylinder. I can measure the diameter for the measurement that will drive the measures for an octagon that will then in turn drive creation of our perfect sphere. As noted in previous videos, diameter times 0.293 is the distance from the cylinder's corner to the octagon's corner from either end towards the middle. Diameter times 0.414 is the length of any of the octagon sides and is the distance between the corner marks made with the 0.293 marks. Now I can trim the left end of the cylinder. While I am at it, I will use the octagon side measure to cut a tenon with a diameter equal to this measure. On the right end of the cylinder, I am marking the same diameter directly on wood. On to cutting the octagon by cutting the 45-degree side of the octagon on both ends. Then, following the standard sphere process, divide the sides and divide them again. Using these, I can do a great job of rough rounding for the sphere. Here's one addition to the usual procedure: sandpaper to do a little more for the rough rounding. This is so the sphere will seat better in the cup chucks that are coming up. Over to the cup faceplate phase. One cup faceplate is on the spindle. Another is on the live center. Following the standard sphere process, I first work with my bowl gouge in a shear scrape mode for 3-axis rotations. This removes the residual tenons and perfects the sphere. Following the process, now sand the sphere, starting with 80 grit sandpaper, then 120 grit sandpaper, then 180 grit sandpaper, each with 3-axis shifts. Anticipating the future forming, I'm stopping for now at the 180 grit sandpaper. I have adapted a cup faceplate with indexing marks and holes. There are other ways to do this. Essentially, I want to divide the sphere by 4 equal sides to be used in the next step. Time for the multi-axis fun. Using the center core and a transfer punch, I can measure the distance on each side of the sphere from the headstock to the transfer punch. This is the best way that I have thought of to ensure that the old axis is perpendicular to the original. I combined that with matching the line that I marked earlier on both sides. This aligns the sphere in all 3 dimensions. For cutting, I'm using what is essentially a 1/4-inch round nose scraper, even though it is more spear-shaped. Carefully, I cut a cove to a good depth, then flare out the corners. For this operation, the wood must be very securely held between the cup faceplates. I must be gentle so that the sphere does not catch and spin or shift. Once I am happy with the cut, I sand this cove through the grits. With the finer grits, I also sand on the sphere on each side since I did not sand it earlier. Now the second cove setup. Again, use the center hole and the transfer punch and the marked lines to align the sphere again. Again, with the small scraper, I cut the cove. I stop to evaluate the cove, particularly the depth. My target is to match the first cove's depth. I cannot overcut the cove since I cannot go back to the setup for the first cove. It is my one and only chance to match depths. And sand the cove again and the surrounding sphere surface. And apply shellac now to this cove, but also the sides outside the cove. I probably should have applied finish when I finished the first cove, so now I have to finish the entire body. A note about cup faceplates. For this project I used the two at top right. The one at top right was on the small side as I needed it to span the cove that was previously cut. Mine are all on threaded blocks, but this is not required. Other turners embed a steel nut to make their faceplates. This is more practical for a 1x8 TPI spindle, as these nuts are more reasonable than the 1¼ x 8 TPI. The larger nuts are harder to find and quite expensive. A third alternative is to mount the cup faceplate to chuck jaws. However, this may lead to greater variance between mountings without special care. For the live center, I love my live stale sock chuck adapter, which enables the same cup chucks to be used on either side. It only comes 1x8 TPI, but a small adapter takes care of that. My base wood is poplar or maple, at least for the threaded portion. I have dozens of threaded faceplates that I use in a slew of different applications. I have but seldom used a 3/4x10 TPI tap that matches my live center. For a top finial, I have a piece of dry hazelnut harvested again from my yard. I like it because it is quite light in color and smells great while I turn it. I'll spare you the rough rounding and the first mounting tenon to go directly to the spindle turning, starting with a spindle gouge. As I prepare the tenon to attach to the body, I experiment with a badan. I would like to do more with a badan, but I'm not comfortable with it yet. For this purpose, it is a skew whose edge is perpendicular to the steel, enabling easy access to the tenon in a tight spot. Once the tenon is sized for the body center hole, I move on to form the finial. After sanding, I apply shellac and then reverse with the tenon into long-nosed jaws to drill for a mounting hole. A wire-wrapped loop will be CA glued into the hole. Since a drill at this small size flexes wildly, a center drill to start is very useful. The bottom finial is the same dry hazelnut. I follow the same process as the top finial, except for the gravitational influence on the design. The smell is still pleasing. One note is that it is difficult to size a tenon for a 1/4-inch mortise or hole. I would rather be slightly large than slightly small. I have a complete set of graduated drill sizes to slightly remount the hole for a good fit. This ornament is headed for a Festival of Trees charitable fundraising event. I missed the annual ornament challenge that I hosted for 14 years. However, the past year's results are still on the web at www.ornamentchallenge.com for your inspiration. Please give this video a thumbs up and subscribe to my website, as well as on YouTube. When you subscribe to my website, I email when there is a new video ready. This is a more reliable process than YouTube's wandering algorithmic recommendations. Please share my videos with your friends. I try to keep them short and to the point. I appreciate your comments and questions. Please wear your full face shield whenever the lathe is running.